Dear students, this is my 16th video for Unit 1 of Engineering Thermodynamics course. I am very happy that almost I have covered all the topics in detail in the first unit, so that we will move to the problems using the concepts and laws and the equations which we have come across in the first unit. Okay, so I hope that in the last video, 15th video, I have recalled you the various topics we crossed during the path of first unit, and also it is very essential and mandatory that you should learn the topics and understand the concepts, and then only if you are exploring the problems you could able to understand the data and the conditions given in the problem, so that applying the values in the right place and to find out the right solutions is possible. Okay, so let us move and solve the problems one by one. In this video I am delivering 3 problems. Okay, try to follow me. So here the first problem about a piston and cylinder machine containing a fluid system. So a fluid is moving through this piston cylinder arrangement and has a steering device in the cylinder. Okay, so paddle wheel. The piston is frictionless and it is held down against the fluid due to atmospheric pressure of 101.325 kilopascal. The pressure is being given, and the steering device is turned 10,000 revolutions with an average torque against the fluid of 1.275 Newton. Meanwhile, the piston of 0.6 meter diameter moves out 0.8 meter, and find the net work transfer for the system. Okay, so here work done, first we will find out so according to the data, first you can draw a simple piston cylinder arrangement, and this is that weight which was hanging against the gravitational force, and here you have the fluid systems, and now here the piston diameter is given as 0.6 meter, and it moves about the length of about 0.8 meter, and how many turns this paddle wheel is making is 10,000 revolutions. Okay, atmospheric pressure is being given as same normal atmospheric pressure. Now first we will find out what is the work done by the steering device upon the system. Okay, by this steering device, what is the work done on that fluid. Okay, steering is delivering the work and that is taken by the fluid. Okay, so this steering device is working against the resistance given by the fluid, right? Okay, so this is where here why we are bringing this formula 2 pi nt means it is nothing but due to the torque raised by the rotation. Okay, so 2 pi nt. So t also has been given and number of turns also given in the problem, so that you got it is as 80 kilojoules. And this is negative work for the system. Already I told you here. This is the system, that is piston cylinder with the fluid is your system. So this paddle wheel is steering, okay, and it is giving the work to the system. We want work from the system, and then only it can be considered as the positive one. So here the work done is negative. Okay, work done by the system upon the surroundings. So here it is this is because of that piston cylinder arrangement. So pressure, okay, into this pressure is existing for the force into distance. Okay, so pressure into area will give you force into how much distance it is moving. Okay, so pressure into area, this piston area is working over the pressure of 101.325 for, I told you already in the problem, here it has been given 0.8 meter, it is moving for 0.8 meter, so L. Okay, pi by 4 pi by 4 d squared area into length will give you volume. So volume into P pressure. So PV will give you work. Okay. So here, so this is positive work for the system. This is done by the system. This work is, but that stirring work is negative to the system. So here the net work transfer for the system would becomes minus 80. This is negative, and it is positive. The work done by the piston is positive, work done by the stirring arrangement is negative. So that the net work transfer could be 57 kilojoules. Okay. Then next, a piston cylinder machine contains a fluid system which passes through a complete cycle of 4 processes. Okay, here a piston cylinder machine is there. It complete a cycle of 4 processes. It is comprising a cycle. That cycle consists of 4 processes. During a cycle, the sum of all heat transfer, okay, the cyclic integral of del Q, all the heat transfer is minus 170 kilojoules, and the system completes 100 cycles per minute. Okay, so this is the data for one cycle. Complete the following table showing the method for each item and compute the network output in kilowatt. Okay, so they have given the sum of all heat transfer and they are asking the work output from the net rate of work output from all the cycles. Okay. Here, for each and every process A to B, they have given this out of 3 data is required or required. Here 2 have been given and another one more has to be find out by following the first law of thermodynamics. So for first process A to B, you know very well that del V is the difference of Q minus W. So Q equal to del E plus W. Here you substitute the values for the first process and then you can find out what is del E. Like that for other all the 3 processes, you can find out the missing item and fill the table. Okay, after filling the table, now in the process 4A, in the process D to A, nothing has given. Instead, you know very well that they have given the net heat transfer as minus 170 kilojoules. Okay, so now the system completes 100 cycles per minute. Okay, so heat all heat transfers from the 4 processes would become minus 117 70,000 kilojoules per minute, and then you can also substitute the other values and then you can find out the heat transfer for the process DA. It is become 35,900 kilojoules per minute. Okay, if they give any data that is extra data, means that could be that is suspicious data they are giving me, then it could be used for any finding of any data. Okay, any other data. Now next, cyclic integral of del E equal to 0, since cyclic integral of any property equal to 0. By using this concept you can able to find out the leftover energy, stored energy of the process D to A, and that is also could be find out as this value. And after finding Q for DA and del E for DA process, we can find out the W. Okay, now you can able to fill the table and the data for each and every process. And now here again so now the table becomes like this, and then now the final finding is rate of work output. Here cyclic integral of del Q is equal to cyclic integral of del W, so which is equal to minus 70,000 kilojoules per minute, and you can convert it to kilojoules per second, means you can get the answer in kilowatt. Okay, and we will move to the third problem. Here the internal energy is not directly given and it is given as a linear equation in terms of PV, and they have given the units. Now a system composed of 3 kgs of substance expands from initial pressure of 500 kilopascal to final volume of 0.22 meter cube to a final pressure of 100 kilopascal, which pressure and volumes are allotted by PV power 1.2 equal to constant. Okay, so if the expansion is quasi-static, find Q, del U and W, and in another process the same system expands according to the same PV relationship as in a part A, from the same initial state to the final state as in the part A, but the heat transfer in this case is 30 kilojoules. Find the work transfer for this purpose. Same problem would be repeated with the 30 kilojoules of heat transfer. Okay, explain the difference in work transfer in part A and B. Okay, so now let us start with the initial equation of U, which has been given as 3.56 PV plus 84. So we can find out del U is equal to U2 minus U1, which is equal to 3.56 P2 V2 minus P1 V1. So you could able to find out because of the equation PV power 1.2 is equal to constant, you can write and you can find out the volume V2 because P1 V1 and P2 has been given. So you find out first V2 and then you can find out the del U from this equation. Okay, and then now after finding del U, for any quasi-static process, W is equal to integration of PdV, which is also equal to P2 V2 minus P1 V1 by 1 minus N. So here you can get the work done, and after getting the work done, you know del U, so that you can find out the heat transferred. Okay. Now if heat transfer is equal to 30 kilojoules, then you can substitute that Q in that place, and then you can find out the work done. Okay, and the work done would be changed if Q is changed, but del U will remains constant because it is following a relation of PV here, and that PV is not having any changes, so del U will not change. And in work B, that is second section, is not equal to integration of PdV in first work, since the process is not quasi-static. Okay, so first the process was quasi-static, so you got the work done of about 127.5 kilojoules, and here and the second case, you can see that it is not the quasi-static, so that both are not same is the that is findings. You can write it in your answer. Okay. Okay, we will soon meet in a next video about further some more problems can be explored, and students, I am telling that please be concentrated in theory part. Only if you know the concept, then it would be easy for you to follow the problems. So be confident in your theory part and try to solve more problems, then only it is easy for you to complete the problems in your end semester examinations. Okay, so thanks for patient listening. I am Suja signing off from you, and meet you in next video. Thank you.